Hello everyone, I am Muskan Nagar and today we are going to solve third internal paper of data science. So let's begin. The first question, which paradigm of data research involves asking what problem can be solved given some data? It is data driven. Second, unstructured data cannot be easily stored in. Unstructured data cannot be easily stored in relational databases. The probability of an event E is calculated as sum of probabilities of outcomes of E. E is event. In distributive statistics, which measure is useful for skewed distribution or data with outliers? It is median. Fifth question, during data cleaning, artifacts are irrecoverable information lost during acquisition. Artifacts can be recovered. So it is irrecoverable information lost during acquisition. Sixth question, feature engineering for discrete data includes one hot encoding. The normal distribution follows 68, 95, 99.7 rule. In modeling, the error term E consists of reducible and irreducible errors. Outcomes Razor suggests choosing the simplest model with equal performance. 10th question, parametric models risk. Wrong assumption leading to bad result. The parametric model risk wrong assumptions leading to bad results. For classification evaluation, precision is the formula for precision is TP upon TP plus FP, that is true positive upon true positive plus false positive. 12th question, in linear regression, coefficient can be found using minimizing RSS. Logistic regression predicts probabilities using sigmoid. Euclidean distance in Minskov with k equals to n Minskov, value of k in Euclidean is 2. K-mean clustering assign observations to closest centroid. 16th question, decision tree are prone to overfitting. Overfitting is caused by decision trees. 17. The neural network activation function introduced non-linearity. Non-linearity is introduced by neural networks. Hadoop's HDFS provides high throughput data access. And SQL to combine rows from two tables based on related columns, we use join method. Python DQ supports append and pop from both ends. Next section is with MCQ with combination of correct options. First question, the following are types of data mentioned in data science. Here J is structured, K is unstructured, L is quantitative and M is categorical. These all are types of data mentioned in data science. So the option A, J, K, L and M, structured, unstructured, quantitative and categorical. Next question. The following are probability concepts. Independent events E equal to A intersection B equals to A probability of A into probability of B. K says Bayes theorem P of A given B equal to P of B given A into P of A whole upon P of B. L is expected value sum P of S into V of S. M is variance equals to lambda. Here independent event A intersection B equal to P of A into P of B is correct. The case statement that Bayes theorem is correct formula, and the L expected value sum of P of S into V of S. The following are data cleaning method for missing values. J is drop records, K is mean value imputation, L is nearest neighbor, M is outlier detection. Here drop records, mean value imputation and nearest neighbor. These are the methods for data cleaning. 25th question. The following are distance measures. Manhattan k equal to 2, k equal to 1, Euclidean k equal to 2, cosine for vectors, KL divergence for probabilities. Here all the options are correct. Manhattan k equal to 1, Euclidean k equal to 2, cosine is for factors, and M KL divergence for probabilities. Next section we have match the pair. We have to match column 1 with column 2. For binomial, we have EV equal to NP and variance equal to NPQ. For normal, we have bell-shaped symmetric graph. Poisson, EV equal to variance equals to lambda, and power law is log, long tails, and Pareto. Next, 27th, reducible errors. Reducible errors can be minimized by better techniques. Irreducible errors cannot be reduced. Overfitting, high variance model noise, and underfitting has high bias and misses relations. So option A is correct. 28th question, linear regression. Linear regression will match with predict numerical and minimizes RSS. Logistic regression predicts probability sigmoid. K-mean, clustering and centroids. Decision tree, binary branching prone to overfitting. Decision tree is prone to overfitting. 29th question, HDFS. HDFS will match with distributed file system. Map reduce. This will match with parallel processing paradigm. YARN will match with job scheduling, reduce management, resource management. DSpark will match with in-memory processing RDDs. The last section is assertion and reason. Here, 30th question, assertion says that correlation does not imply causation, and reason is it measure degree of relationship but not cause effect. Here, assertion and reason are both correct, and reason is correct. R is correct reason for assertion. 31st question, assertion is gradient descent uses linear rate alpha for step size, and reason is it minimizes cost and linear regression. Here both A and R are correct, and R is correct reason for assertion. 32nd question, neural networks are universal approximator. Reason, they can approximate any complex function with enough layers. Here, assertion A and reason R is correct, and R is correct reason for assertion. 33 question, assertion A equals to in SQL join combine two rows based on related columns. Reason, it handles data from multiple tables. Here both A and R are correct, and reason R is correct assertion of a correct reason for assertion A. Next section is about ordering the types. Arrange the steps in K-fold CV in correct order. J is divide data into K folds. K is train on K minus 1, validate on 1. L is repeat K times. M is average errors. The first step is divide data into K folds. Second step is train on K minus 1 and validate on 1. Then next step is repeat K times, and at last average of errors. 35th question, arrange the gradient descent algorithm in correct order. J is compute gradient, K is update parameters, L is choose learning rate, M is repeat until convergence. The first step is choose learning rate, second step will be compute gradient, third step is update parameter, then the last step and repeat until convergence. 36th question, arrange the K mean steps in the correct order. J is assign to closest centroid, K is random initial assignments, L is compute new centroids, M is iterate until no change. The first step is a random initial assignment. We have to assign random values to all the elements. Then the next step is assign to closest centroid. Then the Lth step, compute new centroids, and at the end, iterate until no change. Arrange the map reduce process in correct order. J is map process data to new key to key value pair. K is shuffle the sort. L is reduce aggregate. M is output result. The first step is map process data to key value, and then next step is shuffle and sort, then reduce aggregate, then at the end output results. 38th question, arrange the neural network training in the correct order. J is forward propagation, K is compute loss, L is back propagation, M is update weights. So the first step is forward propagation, then compute loss, then back propagation, and at the end update the weights. 39 question, arrange the PCA steps in the correct order. J says standardized data, K is compute covariance matrix, L is find eigenvectors, M is project data. The first step is standardized data, then kth step compute covariance matrix, then find eigenvectors, and at the end project the data. Last question, arrange the Hadoop component and data flow in the correct order. J is HDFS storage, K is YARN scheduling, L is map reduce processing, M is output to HDFS. The first step is HDFS storage, then YARN scheduling, then map reduce processing, and at the end output to HDFS. So the third entire paper is done.